There are many different forms of model processing, like code generation, model execution or analysis, simulation, and many more. For any form of model processing, we need a tool. In this video, I will give you an overview on the general architecture of a model processor using the example of MontiCore's standard architecture. Let's start with an external view on such a generator. First of all, we need a non-empty set of models that should be processed. A generator is basically just a tool that reads those input models, checks their correctness, and transforms them into generated code based on predefined frameworks, platform-specific code, and the operating system. In practice, we often need parameterized generators that add technical details and allow to fill adaptation points through scripts and generator templates. Generators have to be highly flexible and smart to incorporate handwritten code, platform-specific adaptations, predefined components, and project or user-specific preferences. In the generative development process, multiple people, or better roles of people, are involved. The input models are designed and provided by the application modeler, who, in general, is a domain expert and does not have to be a programming genius. The generator customizer, or toolsmith, customizes the generator to fit the project's needs. He can, for example, add project-specific scripts or introduce templates that provide code snippets to be copied into the generated code. A component provider has developed reusable components, but is rather independent of any generation. Then there's the application programmer, who writes code to complement the models and thus to complete the application. And finally, the tool provider, who has developed the generator and runtime system. Depending on the project, some or all roles are assigned. Typically, the tool provider does not even know about the project. Then again, application modelers and programmers are essential for any project involving generation. Now, let's dive deeper into the generator and get an overview on its internal architecture. In general, a generator consists of a front end, in which the models are loaded, a center part doing some internal transformations, and a back end, in which the internal representation is mapped to the target artifact. At first, the model loader handles the loading of all models and transforms them into an internally accessible structure. MontiCore mainly uses parsers to produce the internal structure, which is called abstract syntax or AST. In the front end, MontiCore also uses data structures and functions to load further models and to check context conditions of the input models. This is necessary for well-formedness of the input AST. The center part is used to transform the input AST to an output AST, which is a rather complex task. At last, the back end focuses on the generation of artifacts like results, code, or reports. MontiCore uses the FreeMarker template engine in its backend to process the output AST together with a number of standardized as well as project-specific templates. Through so-called hook points, MontiCore's template engine is highly configurable and adaptive. All three processing steps are connected via a workflow execution written in a Groovy script. An additional function library helps to build symbol tables, arrange transformations, set template configurations, and much more.